Welcome back, chemistry fans. Today, what we are going to do is our warm-up for day 41. And what we're going to do is a little bit about this lattice energy that we talked about last time. So let's jump into it and let's practice this up. So these are going to be a little bit different, and that's okay because it's a learning environment that we're in right now, harmless stuff. Notice this is that Born-Haber process. And what we're trying to understand about it is how do we show the same process with the numbers, but it's in a visual method. So what we've got to do is add up all the numbers that are in these. Now, in these Born-Haber processes, they start, just as they say here, on the left, and they go in a clockwise fashion until you come down here. So we'll take lithium and fluorine, and we will make lithium fluoride. Now, normally, all we got to do is just add up all of the values that are listed in this graph along the way. Nothing special about that. So all we got to do is get the overall amount of energy it takes to make lithium fluoride. And in each one of these steps, the first step, we are taking lithium and turning it into lithium gas. So it went from a solid to a gas. That's how that changed. Then in the next step, we're going to use ionization energy. We're going to turn lithium gas into a lithium ion. Then in the next step, we are going to split apart F2 and turn it into regular F, and that adds another 77. Now we start putting things back together. That fluorine is going to become a negative fluorine ion, and it releases, so it's a negative 328. And then finally, those two pieces are going to come together to make lithium fluoride that releases a negative 1047. So we're going to put all these pieces together. 161 plus 520 minus 328 minus 1047, and your answer is negative 694. Kilojoules is the unit on that one. So kilojoules is the unit, heat. All right, question number 2. Now, this one's a little tricky, so stay with me here. They don't tell you what the formula for cesium oxide is. Cesium oxide is in the first column. It has a charge of +1. Oxygen is in the 16th column. It has a charge of -2. So what's going to happen is you crisscross applesauce, and you end up with CS2O. Now, normally, we would look for the mistake, and you would have honed in right there. You just said, there's an inconsistency. The O2s, we need it. But that's not correct this time, because notice, we only need one oxygen. So what instead needs to be doubled, the mistake is right here. We need to do 2 cesiums. So be careful that the formula matches what you need it to do. So we're going to still add up everything. That's what we've done before. But this time, instead of it being doubling those oxygens because it's inconsistent, we needed to recognize that the cesiums were inconsistent. So negative 233 plus 78 plus 78, that's 2 times 78, plus 375 plus 375, that's 2 times 375, plus 494 minus 141 plus 845. Add all that together, and this time our total is 1871 kilojoules. That's how much energy it's going to take to make that molecule. You're going to have to add that much, whereas on the previous one, it was going to release it. Okay, this is our warm-up. Hopefully, it rings true with you about how to calculate the lattice energy, even if there's a really tricky part or if there is that Born-Haber very confusing graph. Thank you very much. Hope that you enjoy your time away. Bye. Without me, that is.